So one root of the equation is the square of the other root. Find the value of k. Then the second is to resolve the given functions into partial fractions. And then number 3 is also testing on quadratic equation with the roots. Lastly is to find the domain and range of the given functions. So let's briefly discuss the solution to the first question. So we have one of the roots of the equation. So the equation is 3x squared plus kx plus 81 equals to 0. So if we let alpha be the root, be one root of the given equation, then the other root would be alpha squared, because we've been told that one is a square of the other one. Now, we are going to use Wiertz identity or Wiertz theorem, which is a theorem that relates the roots of quadratic equation and its coefficients, that if we have a quadratic ax squared plus bx plus c equals to 0, alpha and beta, if are the roots of the equation, then when you add alpha and beta, you get minus b over a, and when you multiply alpha and beta, you get c over a. So this is what we call the Wiertz identity of Wiertz theorem. So alpha plus alpha squared will be minus k over 3, call it equation 1. And then alpha times alpha squared should give us 81 over 3. Call this one equation 2. From 2, we'll have alpha cubed equals to 27, which means alpha is cube root of 27, so which is 3. Now from equation 1, we'll have alpha, which is 3, plus 3 squared, to give us negative k over 3. So 3 plus 3 squared is 9, equals to minus k over 3, which means 12 equals to minus k over 3. So which means 3 times 12 equals to minus k. That's 6 equals to minus k. So therefore, k is minus 36. Then the next question is to resolve the given functions into partial fractions. So the first one, we have 3x plus 1 over x minus 2 times x plus 1. So when you are resolving into partial fractions, the first thing you have to ensure that the given function is, or the given fraction is proper. That means degree of the numerator is strictly less than the degree of the denominator. And in this case, it's so true that that is the case, since numerator is degree 1, denominator is degree 2. So this will be of the form a over x minus 2 plus b x plus 1. So 3x plus 1 over x minus 2 into x plus 1, LCM of the right-hand side will be x minus 2, x plus 1. So we'll have a into x plus 1 plus b into x minus 1. So for the two sides to be the same, then 3x plus 1 should be the same as a into x plus 1 plus b into x minus 1. Now, one way of solving a and b is to expand the right-hand side and compare coefficients, or you can eliminate one unknown at a time and solve for the other unknown by fixing the values of x. So for instance, if I want to eliminate b in this equation, I simply fix x to be 1. So if I let x to be 1, I'll have 3 times 1 plus 1 equals to a into 1 plus 1. This part will be 0. So I'll have 4 equals to 2a, which means a equals to 2. And then so remember, so this should have been x minus 2, x plus 1. So x minus 2 into this LCM is x plus 1. And then x plus 1 into this will be 2, not 1. So this will be 2. So if you want to eliminate x, or if you want to eliminate b, then you need to fix this one to be 2, not 1. So we'll have 2. So we'll have 2. So this will be 3. 3 by 2 is 6 plus 1 is 7. So a will be 7 over 3. So make that correction. So you're saying that now our equation is 3x plus 1 equals to a into x plus 1 plus b into x minus 2. So to eliminate b in that equation, we fix x to be positive 2, so that 2 minus 2 is 0, and then we'll not have a b term. So let x to be 2. So we'll have 3 times 2 plus 1 equals to a into 2 plus 1 plus b into 2 minus 2. So this part will be 0. So 6 plus 1 equals to 3 times a. So 7 equals to 3a, which means a is 7 over 3. And then to eliminate a, we fix x to be minus 1. So 3 times minus 1 plus 1 equals to a into minus 1 plus 1 plus b into minus 1 minus 2. So you see that this will give us 0. So we'll have minus 3 plus 1 equals to minus 3 times b. So this will be minus 2 equals to minus 3b, which means b equals to 2 over 3. So therefore, the function 3x plus 1 over x minus 2, x plus 1 will be given by 7 over 3 over x minus 2 plus 2 over 3 over x plus 1. Or you might write it as 7 over 3 into x minus 2 plus 2 over 3 into x plus 1. Or you might write it as a third into 7 over x minus 2 plus 2 over x plus 1. Then next, we have 1 over x squared minus a squared. So remember, a is a constant. So we know that these are difference of two squares, which can be written as x minus a times x plus a which will be a over x minus a plus b over x plus a. So 1 x minus a, x plus a, LCM is x minus a, x plus a. So we have a into x plus a plus b into x minus a. So for the two sides to be the same, then one must be the same as a into x plus a plus b into x minus a. So we let x to be a to eliminate b. So we'll have 1 equals to a into a plus a plus b into a minus a. So which means that this part will be 0. So we'll have 1 equals to 2a times a. So which means capital A is 1 over 2a. Then we let x to be negative a to eliminate a, so that we have 1 is a into minus a plus a plus b into minus a minus a. So by fixing that, this part will be 0, so that we have 1 equals to minus 2a times b, which means b is minus 1 over 2a. So therefore, 1 over x squared minus a squared would be 1 over 2a. So remember, the value of a is what is given by 1 over 2a over x minus a plus minus 1 over 2a over x plus a. Or you can write it as 1 over 2a into 1 over x minus 1 minus 1 over x plus a. Then the next question, if one root of the equation 2y squared minus ay plus 64 equals to 0 is twice the other, then find the value of a. So let alpha be one root, which means 2 alpha is the other root. This is also testing on the Bates identities, such that the equation given is 2y squared plus minus ay plus 64 equals to 0. So when I say alpha plus 2 alpha, I should get negative of our b in this case is minus a over 2. So we get the same as a over 2. And when I multiply alpha and 2 alpha, I should get c, which is 64, over a, which is 2, which is nothing but 32. So call this equation 1, call this equation 2. So 3 alpha equals to 32. Okay, so this is this product, not summation. So when you multiply the two roots, this 2 alpha squared, you should get c over a. Remember what is happening here is that Vet's identity says if I have a y squared plus by plus c equals to 0, and alpha and beta are the roots of this equation, then if I take alpha plus beta, I get negative b over a. And if I multiply alpha and beta, I get c over a. So this is what we are applying, the so-called Vet's identities of theorem. So which relates the roots of the quadratic and its coefficients. So that's here, this sign is multiplication. So alpha times 2 alpha is 2 alpha squared is 32, which means alpha squared is 16. So alpha will be square root of 16, which is plus or minus 4. So when alpha is minus 4, from equation 1, we'll have minus 4 plus 2 times minus 4 equals to a over 2. So this minus 4 minus h equals to a over 2. This means minus 12 equals to a over 2, which means a will be minus 24. And when alpha is 4, then in equation 1, we have 4 plus 2 times 4 equals to a over 2, which means 4 plus h is a over 2. So 12 equals to a over 2, which means a will be 24. So therefore, a has two values, either minus 24 or a equals to positive 24. Lastly, find the domain and range of the following functions. So the first function is f of x equals to the square root of x squared minus 100. So to determine the domain, we note that this being a square root function, we expect the number inside the square root to be non-negative. So it should be greater than or equals to 0, which means x squared should be greater than or equals to 100. So x should be greater than or equals to, so which means that these are the boundaries. So you draw a number line here, minus 10. So this is 0, this is 10. So there are two main numbers that are going to help us test valid values for x. So this minus infinity, positive infinity. So if I pick any value, so remember we have an x squared minus 100 as the number inside the square root sign. So there are these parts, there's this B, and then there's this C. So the two numbers minus 10 and 10 split the number line into three parts, from minus infinity to minus 10 to 10, and then 10 to infinity. So if I put 0 here, which is a number between minus 10 and 10, so 0 squared minus 100 is going to give me minus 100, whose square root is undefined. And similarly, if you put any other number between minus 10 and 10, in this equation here, you are going to get a negative value, which is undefined for square root. So things in this interval are not applying. But if I put minus 10, I get minus 10 squared is 100, minus 100 is 0. So square root of 0 is 0. So 10 itself is fine. Minus 10 itself is fine. Similarly, put 10 here. You square, you get 100 minus 100, 0. Square root of 0 is 0, which is a value that is defined. So also 10 is also correct. Pick any number in this interval minus infinity to minus 10, say minus 20. If I square minus 20, I get 400. 400 minus 100 is 300. So this being a positive number, I know that the square root will be defined. So also all values within this interval are also correct. Similarly, if I put a number, pick a number in this interval from 10 to infinity, say 20, I fix into this, I'll also get x squared minus 100 being positive, whose square root will be defined. So also all numbers within this interval will also work. So which means values of x which makes this function to be defined would be values which are from minus infinity to minus 10, together with values from 10 to positive infinity. So the only values which do not apply are values within from minus 10 to 10, excluding the extremes. So therefore, domain will be minus infinity to minus 10 union 10 to positive infinity. And then this being a square root function, where the range or at the range of the function, you expect the square root, the value of the square root to start from 0 up to infinity. So range is 0 to infinity. The next function was g of x given by 1 over x plus 3. So the first thing is that domain are this being a fractional function or a rational function, we don't expect to get a 0 in the denominator. So we remove all the possibility, all but to give us a 0 at the denominator. So this means we'll pick any other value apart from minus 3. So this will be the domain. All real numbers except 3. Range. So range, this being a fractional function, then we can get any number apart from 0 for this given quotient. If you pick either positive, any number apart from minus 3, this quotient 1 over x plus 3 will give all other possible real numbers except 0. So say all real numbers except 0. Or simply g of x cannot be 0, but any other value of x will apply. Just know that there's a difference between, in the first case, if we define the function in this way, 100 minus x squared, then we'll say the domain will be 100. We expect this number, 100 minus x squared, to be greater than or equals to 0. So 100 greater than or equals to x squared. So plus or minus 10. Now, when it comes to testing, you'll have negative 10, 10, positive infinity, and negative infinity. So still we have 3 intervals. So there's this A, there's this B, there's this C. So if you pick a number in this interval from minus infinity to minus 10, say minus 20, if you put minus 20 here, so you'll have 100 minus 20 squared. So 100 minus 400, which will give us minus 300. And square root of this one will be undefined. So we eliminate this section or this interval. But if I put 0, which is between minus 10 and 10, I'll get 100 whose value will be defined. If you put minus 10, you get 0, which is whose square root is defined. Also 10, you get 0 whose square root is defined. But if I pick a number, say 20 in this interval C, I also get negative 300 whose square root will not be defined. So I also eliminate this interval. So for this particular function, the domain becomes the interval from minus 10 to positive 10. So check that when you write 100 minus x squared square root is different, has a different domain and has a different domain to x squared minus 100. But all of them range will be from 0 to infinity.